So in question 56, we've got a bucket being pulled up from somewhere, and initially the tension in the rope is something. So there's like two ropes over it, so a single rope that's connected over a pulley in the first case, and then in the second case we just have a rope going over a pulley, so it only connects onto the bucket once. And it wants us to know, for the second case, what is the tension in the rope. All right, so let's think about how we'd calculate the tension in the rope in part B. So we're going to have, let's call this part B. Now in part B, let's draw the bucket. So here is my bucket. And acting on that bucket, we have two forces. We're going to have the weight of the bucket acting downwards, and we're going to have the tension force from the rope acting upwards. And we're told that the bucket is being pulled up from the well at constant velocity. So we can say, since bucket has constant velocity, that means that it has no acceleration, which means that the net force acting on it is 0. And so if we know that, then F net, so which is going to be the magnitude, is just equal to the tension force, which is acting upwards. And let's set up a coordinate system as usual, so we'll call this X and Y. And so the tension is acting upwards, so I'll just give that a positive sign, and the weight is acting downwards, so I'll give that a minus sign. And we know that it has constant velocity, so the magnitude of the net force has got to be 0. So this is equal to 0. And so we find that the tension in the rope, which is what we're asked to find, is just equal to the weight of that bucket, which we don't know. So that's not going to do us much good immediately. However, we do have a part A. So in part A, let's draw what's happening in part A. So in part A, what we have is, again, we have the bucket. And again, it's being acted upon by its weight. And this is the same bucket, so it has the same weight. Only this time, it has a different tension force acting on it, presumably. Because I see that this rope connects onto that bucket twice. So both ends of that rope are connected to the bucket. And since the tension in the rope is 92 newtons, that means there must be two lots of that 92 newtons acting on the bucket. So I'll call that twice TA. And we know something about TA. We know that the tension in the rope in the case of part A, or its magnitude, is equal to 92 newtons. And again, since we have constant velocity, we have that constant velocity that implies that the net force is 0. And what is that net force? Well, in this case, the net force is going to be two lots of the tension acting upwards. So we're going to have twice this TA minus the weight of the thing is equal to 0. And so this tells us that the weight of the bucket has got to be twice that tension force. So let's just call this now equation 1. And we can say, plug into equation 1. And what that gives us is that the tension in the rope in the case of part B is going to be equal to the weight, which is just twice the tension in the rope in the case of part A. And since the tension in the rope is 92 newtons, it's going to have to be 184 newtons. So this is going to be equal to 184 newtons is the tension in the rope in the case of the second drawing.